Hello everyone. My name is Matthew Chang, and I am presenting on the topic of blue light and sleep. This is for the fall 2024 semester for PHED 130. So, to begin, I chose this topic because I have very little knowledge on the subject matter. As I was growing up, I was warned by my parents quite a lot about my screen time usage so my eyesight wouldn't get worse and so my sleep schedule wouldn't get messed up. I had a preconception that blue light was quote unquote bad. However, as you'll see and hear during this presentation, blue light itself isn't necessarily bad. It's only in certain conditions can it pose harmful. I also chose this topic because I've heard some mixed opinions on this subject from friends. Some have said that they think this is like a myth. Others have said that others take as many preventative measures as they can. Lastly, my initial intentions from my selection was that I could learn a little bit, I could take something away from it, and in the end, I hope you can as well. So, getting into it, we need to ask the question, what is blue light and why is it so important? In brief, blue light is a high energy, short wavelength light that is found in both sunlight and electronic devices. It is important because it directly suppresses melatonin, the hormone that regulates our sleep. More on that later. We can take a deeper look into blue light by looking at its properties. As we know, light is both a particle and a wave. Blue light's exact wavelength ranges between 380 to 500 nanometers. This is in the UV-Vis light range, crossing over into the indigo and blue, which is where it gets its name from. And as I've said before, blue light can come from the sun or from our devices. I've put in the slides here that the blue light emitted from the sun can be seen as good, whereas blue light emitted from our screens can be seen as bad, since excess blue light from our screens can affect our circadian rhythm. The circadian rhythm is basically our body's 24-hour internal clock that regulates our body's periods of sleep and wakefulness. Excess blue light exposure can, delay melatonin release, shifting our circadian rhythm back and making it harder to fall asleep. However, there are ways to quote-unquote fix our body's circadian rhythm. The simplest solution would be to hold a consistent sleep schedule. Another common method is to take melatonin pills or gummies right before you fall asleep, and these can be commercially purchased from your local CVS or Walgreens. So to reiterate, melatonin is a hormone that signals our body that it is time to rest. If we look deeper into how melatonin affects our body's circadian rhythm, there is a simple yet important pathway that regulates our pattern of sleep and wakefulness. So this slide is a figure that contains the pathway that I'm about to tell you. I will primarily reference the top half of the figure, so yeah, we can get into it. So when blue light is exposed to us, there are these specialized cells in our eyes called intrinsically photosensitive retinal ganglion cells, or IPRGCs. These cells pick up the blue light and send signals to the brain's suprachiasmatic nucleus, or SCN. You can think of the SCN as the control center for our circadian rhythm. When these signals are received by the SCN tells the pineal gland to stop the production of melatonin. However, when there is no blue light present, the IPRGC cells stop sending signals to the SCN, which allows for the production of melatonin. Melatonin thus produced binds back to the SCN and tells the body that it's time to rest. And these downstream mood effects that you see in the bottom right corner will be discussed later. Now that we understand the physiological basis between blue light, melatonin, and sleep, we can discuss possible health effects, if there are any. As we know, blue light, especially that exposed from our screens during the evening hours tricks our brain into thinking that it's still daytime. Since this is abnormal, there is a delay of melatonin in our body, making it harder to fall asleep and especially stay asleep. You may have heard, me included, that blue light is dangerous because it can worsen your eyesight and mess up your sleep schedule. Well, according to a study conducted by Sovani et al., they conducted a literature review study that analyzed over 480 recent peer-reviewed publications that discussed anything related to blue light and sleep. During their screening process, they filtered out over 90% of these articles, ending up with just a total of 36 due to their lack of supporting data or eligibility. Jumping straight to the discussions, they found that roughly 50% of their samples experienced more tiredness and worsened sleep efficacy after exposure to blue light from screens during the evening. In addition, a statistic that particularly surprised me was sleep quality, sleep duration, and sleep latency were not significantly affected. This conclusion raises the question in my head of whether an individual's effect on blue light is person-dependent rather than something universal. Moreover, I wonder if there is a blue light gene that makes us more sensitive to the effects of prolonged blue light exposure or not. Anyhow, approximately 60% found that their cognitive performance and alertness seemed to increase, whereas their reaction time was decreased. Lastly, 42% found greater irritability, arousal, tension, and anxiety in their mood. Furthermore, those exposed to blue light run a higher risk of insomnia, mood disorders, and other metabolic conditions. In terms of vulnerable populations, adolescents, teenagers, and young adults tend to be more susceptible because their bodies are still growing, and hence their circadian rhythms are more sensitive to change. As I've said before, sleep is essential for our productivity and attention. Lack or disruption of sleep is well known to have adverse physical health effects that primarily attack our immune system. It's also been clearly shown that lack or disruption of sleep can cause cognitive impairment, especially in younger populations, and can cause a greater risk for mental conditions like depression or anxiety. Knowing all of this information now, we need strategies to combat high blue light exposure. Some of these you may have heard before, but I'm sure at least one of these might surprise you. From my research, I have gathered 4 ways to reduce screen-based blue light exposure. They are 1. Putting your electronic devices down earlier before going to sleep. This one is pretty self-explanatory, so I won't be getting into it. The next 3 includes enabling night mode on your electronic devices, buying a pair of blue light glasses, and lastly, using natural remedies if possible. Honestly, the natural remedies one was something I've never heard of nor tried myself, so in the future I think I'm going to try this out. So to begin, night mode is a feature enabled on most screen devices, and it acts like a blue light filter. The screen itself switches to include more and more warmer tones, allowing for the production of melatonin, even if this production level is a little bit lower than ideal. What's interesting is that many devices nowadays include an automatic enable and disable feature based on your sleep pattern or when the sun goes up and goes down, much like your alarm clock that helps you get up in the morning. However, when you look at the data, it suggests mixed results. There have been some people that have claimed that they've experienced better sleep when using it, but many others disagree. However, if you haven't tried it before, I do think it's worth it. Something that came up in my research were that there were some psychological and behavioral impacts, you could say, that come from using night mode. They said that enabling it could encourage users to have their devices for longer periods of time in the evening, which could potentially negate these benefits. In addition, the content being consumed also matters, as engaging in stimulating material can keep the brain alert regardless of screen color. The next strategy to combat blue light includes blue light glasses. These blue light glasses are very similar to the night mode feature, as that it helps filter out blue light. It often contains like a yellow or amber tint and will turn everything you see slightly warmer through the lens. However, just like night mode, there have been mixed results. Personally, I do try to wear blue light glasses when I can remember at nighttime because I do see a difference when wearing them. But yeah, it's some people just have not experienced any like benefits from using it. I do think that they are like quite easily accessible. They're pretty cheap, only around $20 to $40. And there are options to have a prescription or anti-glare embedded in the lens, but I don't think it's completely necessary. The last strategy I would like to go over are natural remedies. As I've said before, I've never tried these, so I can't speak on their benefits, but reports have reported consistent results. These include melatonin-rich natural food products and herbal teas like tart cherries, goji berries, tomatoes, walnuts, chamomile tea, and valerian roots. And something I'd like to discuss very briefly is that, well, like, even though blue light affects our sleep and wakefulness, we also know that caffeine affects our sleep and wakefulness, but in a completely different mechanism. So, caffeine is a stimulant in many coffee and energy drinks, and it helps us wake us up and keep us awake, and is not necessarily detrimental unless consumed in excess. So, while blue light delays like production of melatonin, caffeine, on the other hand, blocks our adenosine receptors in our brains, making it harder to fall asleep. Like, these two mechanisms of actions are completely different. And if caffeine is consumed in excess, but especially when it's consumed later in the day, it can prevent sleep onset, possibly reducing the total amount of sleep you get. So, altogether, I thought that this topic was very fascinating to research as this final project. I got to learn a lot more than I was expecting, and I hope that you learned a fair bit too, even if it was like small. I think going forward, diving deeper into this connection of caffeine and how it affects sleep would be very interesting. Furthermore, I think the best implementations you could possibly take into your life if you hope to reduce your exposure to blue light from electronic devices would be to put your phone down earlier before you head to bed and, possibly try these natural remedies. I, for one, will definitely be trying out these natural remedies as soon as possible. That being said, I thank you very much for listening and watching my presentation for PHED 130 on blue light and sleep. And lastly, here are my sources that I use to gather all this information. Thank you.